Burning fossil fuels is contributing to global climate change. Fossil fuels are a finite resource. What will we do when we run out? We must look to alternatives, like algal biofuels. What does it take to produce algal biofuels?
In Iowa, where corn is almost a religion, a new faith may be taking root.
This is algae growing out of solution. It looks just like a cornfield. We run the harvester. This harvester reminds us of a combine pulling off the algae.
Algae? Isn't that something we usually try to get rid of?
You can actually crack the code on actually growing and harvesting algae and getting this biomass. The applications for this biomass is really incredible. You can use it to feed animals, you can use it to feed people, you can take its very high value in proteins. You can use it to fuel your cars, you can get the oil out of that. So when you look at algae, that's why so much interest is in it, because it has such a wide application in so many different sources.
In addition to its biofuel possibilities, algae is already being used in all kinds of ways you might not be aware of. Food products, baby formula, or nutritional supplements like spirulina. Algae contains the all-important nutrient omega-3 fatty acids.
It's all about omega-3s, and the world is short omega-3s. They're long omega-6s and omega-7s, but they're short omega-3s, and algae may have the best ability to solve the shortage of omega-3s in the world at the highest quantity.
Quantity, that's what they're trying to tackle here in Shenandoah, Iowa. In an unusual pairing, a traditional corn ethanol plant is supporting algae production, a next-generation biofuel. It turns out corn has what algae needs.
A third of the kernel is starch, being converted into fuel. A third of the kernel is fiber, being converted into animal feed, and there's a third left. And all that is being converted into CO2 in the atmosphere. So we could actually take that other third of the kernel that we're basically emitting into the atmosphere, capture it, and create a whole nother product around how we convert CO2, warm water, waste heat, and sunlight into algae.
CO2, wastewater, and heat, all byproducts of producing corn ethanol. Exactly what algae needs.
Can we grow, harvest, and extract algal biofuels in New Mexico, even though New Mexico does not grow corn? Researchers at the University of New Mexico are working on how to bring algal biofuels here.
Hello, I'm Andrew Schuler. I am a professor in the Department of Civil Engineering here at the University of New Mexico.
What challenges will you have to overcome to bring algal biofuels to New Mexico?
So the technology is currently that there are some, as I said, there are commercial scale systems that are attempting to make a profit growing algae, acre-sized plots. Notably, in New Mexico, it's a very active area of research thanks to our large amount of sunlight here. Down in southern New Mexico, Sapphire Energy has some large acre scale plots that they are attempting to turn a profit on. There's a number of companies, say in Israel, that are ahead of the game on this. So the state of the art is that there are companies that are actually trying to do this, but there remain significant challenges. And you can think of it in terms of the economic challenges, how do you make a buck? And that's very much linked, of course, to making the whole process energy positive. So you need to be able to grow algae in significant quantities at a fast enough rate that you can harvest them and then have the whole production process for algal biofuels to have as little energy input as possible, that you can then get more energy out of it than you put in. Otherwise, what is the point? So that's a multi-step process, as you'll learn about in your review of the science. And major challenges include demands for water, evaporative losses in high heat conditions. If you cover a system, say having a closed system, well, there's two types of systems: open systems like a pond or a raceway, and there's also closed systems like tubular reactors. A raceway, of course, will have large evaporative losses, but it will stay cooler. A closed system like a tubular reactor will not have won't have the water losses, but it will also heat up a lot in a place like New Mexico. So cooling things down is a challenge as well. So water, an issue. Where do you get your nutrients is an issue. You don't want to be having to fix nitrogen from the atmosphere, which is a very high energy process. It makes more sense to, say, combine the process with, for example, wastewater treatment, which is where my research comes in, because you have nutrients in wastewater that can be used to grow algae. Stepping through the process, another challenge is sometimes people work with pure cultures of algae. If you want to work that as a single strain of algae as opposed to a mixture of a whole bunch of different algae. If you're trying to work with a single strain, that's a challenge because you can have contamination easily coming into your system. So maintaining a pure culture is a challenge unless you decide to go with a mixed culture, a lot of different algae, in which case the challenge is understanding how the process will affect that community composition. Continuing downstream, another in the process, that is, another challenge would be getting the water out of the algae, separating the solids from the water, because you need to be able to get a very concentrated solid stream to then be able to process and get create a biofuel from that algal biomass. Sort of the classic step after you get enough water out is that, and that itself is a huge challenge, and that's where some of the research on my lab is coming in. The next step would be how do you transform the oils that are produced in the algae into a biofuel, which is where you chemical engineers know your stuff, right? And that's a pretty well established chemical reaction called transesterification. But making that cost effective it can be really a challenge in terms of separating, again, getting out the non-oil component of the algae from the oil component of the algae. Alternatively, hydrothermal liquefaction is an alternative that you should look into that is possibly going to be more cost effective than transesterification. Those are some of the major challenges that I would say exist with algal biofuels.
What can you do?
For you embarking on this journey of algal biofuel research, there's a number of good reviews out there, and there's even a lot of good web resources on algal biofuels. The state of the art is actually there's companies out there that are receiving Department of Energy money that are fairly large facilities. They have very good websites. That's a good place to start. But that's kind of, as you're aware of, anything you find on the internet that isn't peer reviewed, you have to take with a grain of salt. It's not necessarily up to date. It could be somebody's opinion. So you need to back that up with a scientific literature review, which I'm sure your instructors will help to guide you on how to do.
Pick a rural community to grow, harvest, and extract oil from algae.
You know, there's great minds at universities that supposedly can help solve the challenges that are involved with algal biofuels.